warm welcome to everyone who has been attending this session. So, uh, thank you everyone for joining us for this webinar on QuickCast SLA Patterns for investment casting, powered by SRT shreerapidtechnologies with 3D systems, with our partner 3D systems. And hi, I am Assistant Marketing Manager at shreerapidtechnologies. My name is Sonal Khoth, and I will be the moderator for this webinar. Uh, let's move on with the introduction to our panelist. His name is Magesh Pandey. With over 8 years of experience in additive manufacturing, Magesh has been instrumental in deploying advanced 3D printing solutions across diverse industries. He is highly proficient in multiple 3D printing technologies and specializes in optimizing digital workflows for investment casting and holds a certification in 3D ceramic printing from 3D Ceram. This is the agenda for today's webinar. First, we'll have a quick overview on who we are as SRT and how we are shaping the future of additive manufacturing. Then we'll jump on to the main webinar session. And after the webinar session, we will have an interactive poll, quick interactive poll with few questions. And after the interactive poll, we will answer the questions by our audience. So without much further ado, let's begin. Now I hand it over to Magesh to take us through the topic today and share his insights. Magesh, over to you.
Thank you all of you today to join me with this webinar. This is today agenda. Before going to topic, I would like to introduce my company, which is shreerapidtechnologies. The company is founded by 𝗪𝗘𝗕𝗜𝗓𝗓 and Shashir Kumar in 2007. So we are into digital manufacturing solution provider for the long history. Along with, we have a top class customer innovation center for metal and plastics in Mumbai. Where we are today, we have 18 years of industrial experience, more than 650 printer installation, dedicated team, application and service. Our branch office located in Bangalore and Delhi. Head office located in Mumbai. Rest other place we have sales presence. These are some of the images of our plastic and metal CAC. You can see, we regularly doing part printing, benchmarking, demonstrations, material development. So where you can see all the material, all the machine under one roof. shreerapidtechnologies, we have an experience. We are one of the oldest 3D printing company in India. So we support digital manufacturing solutions. For that, for reverse engineering designs, we partnership with 3D System, Metallize, Optum, Choice. To produce in-house metal powder, we have partnership ATO. For 3D printing, we partnership 3D System. It is one of the major OEM, well-known OEM in globally, who's the father of the 3D printing. Actually, we in the 3D printing world. And BMF, where you can print, it's a micro SLA where you can print 25 to 50 micron feature when you require, very tiny component, very tight tolerance. So this is the solution. 3D Ceram. So we have partnership for technical ceramics part printing. Rice CD is one of familiar brand they have world class professional grade printers like FFF based solutions, DLP, and desktop SLS and Micron Titanic. For inspections, we have partnership with JICE. For post processing, we are tied with Dimensions. So SRT, we have all the solution in 3D printing from right desktop to production grade, SLA technology, DLP technology, SLS technology, multi-jet printing, fused filament fabrication, and direct metal printing. So Today's topic, I'm going to talk about the benefits of investment casting with a QuickCast. To begin, why 3D system has developed QuickCast method. In traditional method, normally it required 100% solid wax pattern from injection molding tool. This process is not only limited to design freedom to allow the engineers and designers, but the process create very large and delicate parts. To produce a mold, obviously it's more expensive and it is slow to produce wax pattern. These are the standard procedure industries or foundry follows for investment casting method. Where 3D printing come to the picture, it is deleting the tool. So which means you no need to tool to make it investment casting pattern. For that you have flexibility. You can change your design. You can print your part, quick iteration. You can print. You can make a complex structures, and you no need to wait for the mold. Mold it takes more time to get it. So that is one of the advantage when you have a quick cast pattern in 3D printing. So rest of the process similar, except this the process changes. So in early 1990, to improve the new way of investment casting process, 3D system has identified to create a 3D printed pattern using QuickCast, that is called QuickCast pattern. So the real value of QuickCast is speed. It comes from the speed. The pattern that previously made, it takes weeks or month, cannot be made in hour or day. So it not only faster, it is allowed to engineers or design which is previously not manufacturable. They use lot of material, more efficient. Mostly in traditional method, you might be aware like you need 100% solid wax. Now it's almost 90% air. This pattern, because of the process, it is very lightweight. Because of the lightweight, it is very geometrically stable. Not only geometrically stable, you can see the picture. It is completely infill structure, so you can ship it easily local or anywhere in part of India. Yeah. So finally, because of the quick iteration, if some component, if you would like to test or get the certification, so investment casting has a wide range of long history to produce metal parts. So we just changing the pattern productions. So you don't need to worry about how the part going to manufacturing it, and it can be produced very quickly. I would like to play the short video about the QuickCast pattern production using 3D printed in a 3D system SLA machine. This is software. You have to import a model, create a support automatically. So it is 3D printed parts. So majority of the material is drained from the vat itself. So you take out the part, clean the support, finish it, then you can move on to your traditional lost wax process to get the metal parts. Yeah, so this is nice image of QuickCast pattern. The left hand side, what you see, that is 80 centimeter of diameter of gas turbine. The metal part is in titanium, casted in titanium. The right side part is, it's a segment component, one of the geometry. So actually, you have no really part size concern. That is the advantage of SLA. You can print any component, any size of component with this SLA system, because you can segment the component, you can print it, you can join together later on, you can go for the casting patterns. So what SLA technology does give you is thermal unique relativity to stay thermally. Compared to the powder bed technology, normally it involves binders or powder bed technology, it heat process. It may shrink a lot compared to SLA technology. What we use, it is ultra low shrinkage epoxy based resin. It's cured by UV laser, and it is not a structure in solid. It is 90% hollow, so it is dimensionally stable. actually it's a cold process, so you no need to worry about the surface quality or maintaining temperature and all. So this is how the advantage of SLA QuickCast pattern. Some more images you can see the left hand side. So it is 1 meter of diameter of one of components. You can see the structures, surface texturing, holes, packets, which is highly complex to produce in traditional injection molding method or wax-based methods. So that's the leverage of 3D printing, where you can produce the complex geometry in a simple way. So this is big industry ducting component for oil and gas industry. It's nearly about 2 kg of part. You could just imagine if the same part printed on wax, how much it is. So it is very difficult to handle when you have a wax because of the lightweight. So you can easily ship it, you can easily pack it. So handling is very easy because of the lightweight structures. And obviously because of the fast production, it is suitable for batch volume productions. This is one of the example of casted part using QuickCast. It's a aluminum gear parts for Formula 1 vehicle. So you can see this something around 50 mm parts with the 50 gauge of parts. You can see the wall thickness of 1 or 2 mm, which is, I'm just pointing out. Yeah. So you can see the wall thickness and structure and the cooling jackets. So it is highly complex to manufacturing using traditional methods. So 3D printing will allow you to create any complex structures. So designers doesn't care about how the part going to manufacturing. So that is one of the best example of QuickCast applications. Normally, when you design the geometry for a traditional method, maybe injection molding or any other process, it may not get as successful. So you have to design to get a real fat according to 3D printing. So you can create a complex geometry, you can print it easily. So in general, any complexity, it increases the process for normal investment methods. But 3D printing doesn't matter, no matter whether it is complex or simple, the cost remains same. So this is a history how they develop QuickCast pattern. They have developed QuickCast hatch, later on QuickCast triangle, QuickCast hexagon, QuickCast diamond. So it's reduced almost weight constraints they create based on the structural integrity, stiffness, maximum amount of material binding during the post process, even the machine after printing. So it has to be the infill structure has to be alternately joined together so that the 0 degree, 60 degree, 20 degree, so that material did not stuck inside the material, inside the component. So that's how they developed the algorithm over the long histories. So some of the example of QuickCast infill. So as I said, due to the nature and structures, majority of the material can drain automatically because of that's how they develop the patterns. So this is some of example of honeycomb and diamond structures. Initially they have developed a honeycomb structure which has consumed more material and some difficulty facing to dry the material from the part itself, and it has high stiffness because of the nature of hexagon. It has all the corners can be connected to each other. So they later on they develop the diamond structure without compromising the structural integrity or stiffness of the parts. They develop the QuickCast diamond structures, and obviously they have reduced almost 22% of material reduction compared to honeycomb structures, 20% faster than the production time when they have diamond structures. QuickCast air, the left hand side it is QuickCast diamond structure, and the middle this is QuickCast air that they developed very recently. So it is almost nothing inside, 90% air. So the ideas comes from the nature. So the inspiration. You can see the structure. It's the leaf, how they uniformly distributed the work, and the webs and drifts So the idea is like minimum amount of material to maximize the stiffness and rigidity of the components. So that's how they take a reference or source from the nature to develop this QuickCast pattern. Mr. Evan Kuster is one of the key drive person to develop QuickCast ad. He is basically from architecture. So we have seen the building frames and waves. So how they incorporate the 3D printing. So the idea is like taking out those structures and inbuilt with the software. So he made a very strong algorithm. It will automatically create a shells inside with respect to their stripes and positions. So this is graphical representative of QuickCast hair, how it's going to look. It's kind of so bubble. It's uniformly distributed on all the area of the part. It is infill structure actually, so that material cannot stuck anywhere on the corner or any of the part size, because even the small amount of material can leads to crack when you work for the investment castings. So they have made a strong algorithm which is highly super lightweight component with this QuickCast air structures. So QuickCast air, as I said, you can see it's almost 90% air, nothing inside in the geometry. So this is how looks QuickCast air parts. So some of the nice images, so printed on QuickCast air. So this QuickCast air has a benefit of a super lightweight component. So the metal can dry automatically. That's how it is automatically the pattern is generated itself, and this in itself it has lightweight. So there are a lot of advantage when you have a QuickCast hair. You can create lightweight component, faster timing, and it is almost 38% faster than the QuickCast diamond structures. So that we have a real benefits of 3D printing with the QuickCast investment casting pattern. Here the some of the example, they have taken the basketball. The left hand side is printed on QuickCast diamond, and the right hand side is printed on QuickCast air. So you can see the weight, how much reduction is almost 50% is reduced compared to the QuickCast diamond. So this is the QuickCast air they developed newly. So they have taken example of traditional methods. So if they consider, if they want to manufacture a similar basketball in the wax, so it's roughly around 6.5 kg. So a 3D system has considered as $5 per kg for an injection molding wax. So something around $30 to produce this basketball in traditional methods. The same way, if I have QuickCast, the same basketball, which is around 230 grams, normally 3D printing cost generally it's around $90 to $100 per kg. So if they consider the same part, is roughly around $25. So the same part in injection or traditional method, it's roughly around $32. The same part in QuickCast 3D printing is roughly around 25. So you can see how the cost drastically change. The very interesting thing is you no need to have a mold out of it. So there is no any tool involved to produce such a components. So that is one of the advantages when you have a QuickCast pattern. So this is some of cost calculation done by 3D systems. So they have printed the basketball on QuickCast diamond structure, and they have mentioned the part weight roughly around half kg, and the metal cost something around $98. The cost around 47 USD for one basketballs. The same part in QuickCast. So as we see, it is around something 231. If we consider per kg of $90, so it is cost around 20.79 USD. So they also compared with the traditional wax method, injection molding wax methods. So they consider $2, $6, $13 with respect to the wax quality. So absolutely there's a story or the real fact of 3D printing when you have. So if you have a larger cross section, complex geometry, 3D printing will absolutely right option to produce your investment casting pattern. So this is some of the build example. So it's a platform images on SLA 750. Actually, we have a three machine. This is the build time example. So uh, we have tried one of the smaller component to produce an SLA 750. Actually, we have three different machine for the QuickCast applications, mid frame, larger, and super larger. So this is a component. The parts is around 90 mm in X, 120 mm in Y, and 110 in Z. So in PSLA, we have build volume of 265, 240, and 350. That is a smaller machine what we have for a cookers application. Then mid, we have project 7000, which is build volume of 380 in X, 380 in Y, and 256 in Z. And finally, the bigger platform, what we have, the image what you have looking at is at SLA 750. So with this platform, we can print it. We can able to print it 46 parts in 27 hours. You can imagine if the same part if you want to manufacture traditionally, how long it will take, and again so you have to pay for the mold and tool and other stuffs. And so you are eliminating tooling cost, you are eliminating manpower. So absolutely, suitable technology for to create a investment carting when you have a batch productions or complex raw materials. So this is some of the industrial case studies. The company name, they're facing some lead time issue and tooling cost issue. To avoid that, they have approached 3D system. 3D system offer the solution for QuickCast build style using it with the federative material. So they have reduced the 3D printed pattern 14 days into 14.5 hours to deliver the compound. So you can see how much drastically reduced when you have a 3D printers. So they almost save the tooling cost, the lead time. They can iterate the multiple designs simultaneously. One more case studies from TechCast. So again, they are facing some issue with quickly developed impeller. So they are facing some issue with because when they change the design, they have to change the mold as well. So 3D has offer the solution with the build style and accurate castable material. They have almost reduced 90% of cost compared to the conventional tooling. So that is you can see that how the importance of 3D printed quick cast using 3D systems machines. So again, not only the cost, they also increase their productivity. They almost increase 66% of compared to the conventional methods, and they can do multiple trials. They can go for printing it. They can change the design. Then again, they can print it. So that's how they develop the components. So the CAC, Customer Innovation Center, Metal and Plastic. This is a solution what we offer in. We do training, benchmarking, application support to find out the right material, right machines, and we help out a project as well. And we do regular on-demand basis services, printing service for bright ceramic, rubber, metal, and quick as investment casting pattern as well. So that's all my presentation. So please reach out to us for any query, any supports if required. I'm happy to support on that.
Thank
Yes,
you.
Sona.
Thank you, Magesh. Thank you for that deep and insightful session. Let's move on to our next Q&A session. So there are few questions which will be answered by a moderator.
So please answer to the question, what is the minimum wall thickness which is possible with a quick cast?
I've answered. I think
Type in. No, you please speak up.
we are right? Yeah, clear.
Hello?
Yeah, sorry. So you need minimum thickness of 2.5 mm. Because with this 2.5 mm, you cannot create infill structures. Then it leads to crack when you're going to investment casting. So above 2.5 can easily create infill structures. Yes.
Okay, let's move to the next
Hope this is
question.
your answer your question.
Yeah, let's move to the next question, Magesh. Aircraft turbine engines needs blades replacement for every overhaul. Is it possible to use 3D print wax model for its investment casting?
Uh, I'm unable to see the questions. Can you repeat on it?
Aircraft turbine engines need
Uh-huh.
blade replacement for every
Mm-hmm.
overhaul. Is it possible to
Okay.
use 3D print wax model for its investment casting?
Yes, possible. But how big the geometry, that is important, because uh, whether we would like to go with the wax or QuickCast pattern, so we need to look at the real CAD model of their geometry.
Okay. So for detailed discussion, sure, we can have a one-to-one discussion and we can discuss. Let's move to the next question.
What is the burnout temperature, Magesh?
Generally, it's ash-free material, free antimony material. It can melt less than 680 degrees Celsius, like wax. So you will get the ash-free of less than 0.05%.
Okay. So,
Let's move
uh,
to the next question. Do
do
you
you,
support with purchase of second-hand 3D printing machines? No, we don't support. Let's move to the next question. How do you increase addition of the quick cast pattern and ceramics?
No, ceramics not, because it is photopolymer resins. But if you would
No,
like to
no,
create
no,
a,
no.
yeah,
Yes, the question is, how do you
yes,
increase addition of quick cast pattern and ceramics?
no, mainly for metals, not ceramics, actually.
Okay, let's move to the next question. No, this is done already.
I'm unable to see the question actually. Generally, it's where it comes. Yeah.
it is in the question threads. If you see a question mark
One
on,
question. Yeah,
yeah,
yeah.
in
I've
that
seen that.
section,
Only one question I've seen it. Mr.
Okay,
Manish, only one question. Yeah. Anyway, you can just write down so I can answer on it.
okay.
let's move to the next question, which is asked by Manish Rao. How to remove trapped resin out of printed pattern and cleaning method?
Yeah. Great question. So super. So generally, as I said, it is 90% hollow, and the pattern that we create, cook as air or diamond, they have created structure. There is no chance to trap the material. So when you prepare the model, you have to give drain hole on the bottom side of the geometry, and top side you have given some vent hole. So when you lift the platform, measure of the material is drained from the hole, from the drain hole. Then later on, you can just use any centrifugal or honeycomb, honey extractor structure, honey extractor equipment. You just, due to the centrifugal force, the minimum of material it's collected on the one side of the parts. Then you can just collect by the pump. You can close the hole, vent and drain, and you can move it for the your traditional investment casting process.
Okay, thank you, Mukesh. Next question. What is the minimum wall thickness?
2.55 mm.
0.5. Let's repeat it again. Okay, there is one more question from Mr. Scott. We tried some pattern but found a lot of resin still present after 3 hours of burnout. Do you recommend any further action?
Uh, So the thing is, before going for the casting, the process, the important thing is, as I said, you have to dry the material completely. So might be which infill pattern you have used. You can try with new Kuka's air pattern. So majority of material can be dried automatically when you come out from the machines. Then I hope you cannot have any issue with that. So
For a
have you
detailed
tried?
discussion, maybe Mr. Scott, we can have a one-to-one discussion. So please, so leave your message with your email ID. We will connect to you and we can organize one-to-one discussion with you. Let's move to the next question. Shankar Vidya. After pattern manufacturing, coating process will be required? Question mark.
Yes, obviously, because anyway, it is going to be melt or burn out automatically. So once you printed, you have to add a sprue these QuickCast patterns. Then you have to dip it on the ceramic slurry number of times to achieve desired shell. Then you have to move for the firing cycles. So ceramic slurry is something is important.
Okay, thank you. Next question. What is the maximum part size to build through QuickCast process 3D printing?
As I said, we have that advantage. So we tried almost 2 meter parts. However, our build volume is maximum 750 by 750, but you can segment your geometry. Once you print it separately, you can join together using patch, one of the solutions where you can join the 3D printing parts. Then you can move for the casting. So only thing is you have to take care of how you're going to melt the process. You need a proper setup on it. Yes.
What is the maximum part which we can print on our machine part size? Magesh?
Under one go, you can print 750 by 750 by 550 mm. Okay.
So
This is
that is
not a
the minimum
maximum.
size which we can print. But as a segmentation, so there is no problem in terms of size of the part. Correct?
Correct. Correct. Correct.
So let's move to the next question. Can you help me make cavities? Yes. So we can have a one-to-one discussion. Let us understand in depth and take it forward if you need to support any benchmarking for you. Okay, let's move to the next question. What is the RA value achievable with minimum post-processing?
So as 3D printer, you can get less than 12 micron because as it is resin component and SLA it's high precise 3D printing technology. So you will get a less than 12 micron as 3D printed.
Okay, thank you. So are you worked previously with any automotive OEMs? Is it possible to print vehicle interiors dashboard
So
from
for
Ford?
interior, we haven't tried, but we can work out on that. How we can support on that. But
So if the
currently, how
question
the
you are asking from the QuickCast perspective or different 3D printing perspective, basically it is possible. We can have a further discussion one to one. Mr. Money. Okay. So sorry. Yeah. So next question, Mr. Money. In the investment casting process, how do you increase the addition of the quick cast pattern and the ceramic, which is asked by Money?
yeah, great question. Actually, we have not tried. We are not aware much on that. So
Okay.
we will
Let's do
connect
the
and support
following,
on.
Mukesh. Please take that question. Let us
Yeah,
answer back to Mr. Money. Yeah.
yeah, sure.
Okay. So let's move to the next question. How do you close the B drain hole?
Yeah, 3D system has the solution. So where you can, it's a very small diameter of 5 mm to 7 mm. So you can use any adhesive, uh, glue on it, both the drain and the vent hole. Then you can sand it out. So absolutely nothing the issue with the filling a wood.
Okay. Next question. What is the epoxy material that is used? Is it available in the market?
Not in the market. It is proprietary material developed by the 3D systems.
Okay. Thank you. Next question. If layer size is 0.1 millimeter, then can we not 3D print part lesser than 2.5 millimeter thickness?
You
I
can print,
repeat
of
again.
course. Yes,
I
please.
repeat again. If layer size is 0.1 mm, then can we not 3D print part lesser than 3.5 thickness.
No, the question is a bit still confused because layer
It's a little bit
thickness,
confused.
it's something is
Yeah.
G resolution, thickness something is X-ray resolution. So there is no relation between the layer thickness and the X-ray size, but the question is quite confused. But how do you relate
Okay.
layer thickness into minimum
It's okay,
part
Magesh. I
size?
think they're asking if it is layer thickness 0.1, so can we print 2.5? Yes, it is possible. Okay, next
Yes, it's possible.
next question. What are the post processing methods?
So generally, we use the honey extractor. Actually, at the time of video, once you print it, it has some supports. You have to remove the supports, sand it completely, close the hole. Once it's done, so you can put a part in the honey extractor. It's a centrifugal rotation the equipment. So with this force, the majority of inside stuck material it comes to collect one place of the geometry. So you can just pinch it. You can suck it using pump, and you can dry it. You can again close and you can finish it actually. So generally, after 3D printing, you required honey extractor based on your part size. It's a rotary equipment.
Okay. Next question from Mr. Shankar. Can it be used for prototype casting or pilot or lot casting? The
Uh,
technology can be used for batch production, prototype production, mass productions.
Actually, mass
Yes.
production, uh, not like similar like injection molding or a traditional method, but absolutely suitable for batch production.
Okay. Thank you. Yeah. Okay. Next question. How do you avoid porosity?
No, actually, when you 3D printed, of course, you're getting a super finished surface part. Might be you have to change your investment casting process methods.
Is there any
Uh,
connection between the resin what you used in the quick then when it goes for a casting process, is there any connection for the porosity, or they have to
Actually,
or, or they have to control in their casting process?
no, it's a both the way actually, not only 3D printing point of view, but whatever the material 3D system has developed, that is, as I said, it is antimony free material, so you can get ash content of less than 0.05%. So they have tested multiple iteration. So in terms of melting point of view or ash point of view, metals are tested. Might be the casting cycle might be you have to change or apply a new method to get a successful component. Or you can try with wax because wax is familiar method. So you will not get any porosity when you go for with the wax.
Okay. Next question from Mr. Krishna. Some aerospace customer demand RA value of less than 1.5 microns. Any suggestions?
Uh, Actually, it depends. Like after casting, you can go for the machining. So there are a lot of machinery, machine section is there, machine tool section is there, where you can control your RA in the metal part size because 3D printed is just a pattern. So you can go
Apart
with
from
second.
machining, it is not possible to achieve 1.5 micron. Is there any other
3D
method?
printing.
Magesh, are you there?
Yes. So with the 3D printing, less than 1 micron, it's complex, especially this quick cast because it involves a lot of structures. But you have to try with your after metal castings. You can do for machining and all to achieve a
Okay, so
desired RA value.
customer is asking 1.5 micron. So is it possible?
So 1.5 micron 3D printing point of view or metal point of view? That's a question.
No, casting. So
So
after
casting
using the
is
pattern, quick
is
cast,
yeah.
after it is done casting, is it possible to achieve 1.5 micron of RA? No, right?
Not sure actually because it is metal point of view, investment casting related questions.
Okay. Let us take that point. We can answer that second point.
Yes, sure, definitely. I'll.
Next point. What is the strongest material this technology can print? And also, what is the tolerance? From Mr. Siddhanath.
Yeah, great. Thank you, Sudhir. So, as I explained, they made an algorithm and they do multiple iteration to develop the infill thickness. So they have tested compression test. So the whatever the by build style they have introduced, we are using QuickCast Diamond or QuickCast as have enough strong to produce your investment casting pattern.
Okay. Next question is there traction for 3D printing of wax pattern in valve industry? Asked by Mr. Saran.
No, not sure. We can connect them later on.
Okay. Next question. Okay. Next question. Dewaxing process.
Mhm.
Autoclave is preferred or we need to do it manually?
Autoclave is preferable. Actually, they have tested it through autoclave, so autoclave is preferable.
Okay. There is one more question from Mr. Krishna. In the example you showed where the resin cost was 20.8 USD, what was the volume of the cast part?
Yeah, so we haven't tried cast part because ultimately we going to
Oh,
compare.
no, no, Magesh, no. There is a sheet which we have shown with the price.
Mhm.
He is
Mhm.
asking what is the volume of that part. There is a value there. Can you please read and
No, they didn't
explain
give a
here?
value. They taken mention of the kg, 6.5 kg.
Okay. I think that is good enough.
Yeah, I have conveyed that during my presentation actually. Yeah.
Okay, good. Yeah. Now, sometimes people miss, we have
Yes.
to answer.
Yeah.
Okay.
It's okay. It's fine. Any question more?
Just give us few minutes. We are just checking. Any questions are left out.
This is also answered. See if any questions are there. No. Okay.
So
Okay. Now, latest question, Magesh. How is the
Yeah.
finishing of the cast pattern and can it be machined further? It's a similar kind of a question. Magesh, can you answer?
Sorry, can you repeat again?
How is
How
the
do we?
finishing of the cast pattern?
Mhm.
What is the finish? What is the RA value before machining with the casting?
Actually, it's depend the geometry. For a plane, you will get a different RA. I don't have exact value of the finish pattern for it. I can check
Okay.
and
Usually
communicate.
10 to 20 micron usually we can consider, and obviously you can do the machining based on your machining parameters. Okay. So good to see still 49 people are there to look into it. So one more question. Can you share the PPT?
Uh,
So as I was late, which is asked by Seven. Yes, I think we can connect to you, Mr. Seven. We can have a one-to-one discussion. We can also share the presentation. So next question, how can be critical inspection method used?
No, they are not familiar on inspection methods.
Okay. So if you would like to do the inspection after the casting, usually couple of methods are there. You can use a 3D scanners. If it is a coarse accuracy between 30 plus microns or even 20 plus micron. If it is less than that, we would suggest you can go with the coordinate measuring machines. So next question, what is the life of quick pattern and how it affected by outside condition like sunlight? Very good question, Magesh. Can you please answer?
Yes, great, superb. So it has obviously epoxy resin, and it affects the UV. So normal like other 3D printing components. So if you keep the component with a normal environment with a less than 30 degree, so you will get a life. So we tested almost 6 months. We haven't seen any warpage or structural collaboration of the geometry. But if you keep an environment of less than 30 degree, then you will get a more life. You can keep it only.
Magesh, if I print the part and if I am not casted, how long I can keep that part, printed quick cast part?
No, that's why you have to keep the part with a proper environment less than 30 degree, maybe 28, 27. So we tested. We have seen almost 3 to 4 months. We have not seen any issues on the printed parts. So because its condition is different, what geometry, which environment are you using, that is very important. But it is surely higher lifer than the wax, because wax you need to maintain the temperature of less than 24 degrees Celsius, and even the small heat it can go up, it can melt, but QuickCast has the advantage of that.
So it get affected with the UV radiation as well as temperature, both.
Yes, yes.
Okay. So let's move to the next question. If there is any other advanced methodology and pattern in investment casting 3D printing process apart from what you shown today.
Uh, no, actually, the QuickCast air, that is the reason development done by the 3D systems. So that is a reason method.
Usually wax and this is the quick cast, correct, right? These are the two methods
Yes.
which can be used. Yeah. Okay.
Yeah.
Good. I think more or less many of the questions has been answered. If anything is left out, I think couple of questions, I think 3 to 4 questions we were unable to answer. We will connect to you. If anybody wish to have in-depth discussion, we would be very happy to come and discuss with you personally. Please let us know. You can leave a comment in the question and answer session itself. Thank you very much for a very active presentation. 47 people still they are active. It shows that the topic was very interesting for you. Uh, Sonal, you want to conclude?
Yeah,
Yeah.
sure. So let's conclude my actually heartfelt thanks to Magesh sharing his expertise. Also, I would like to thank 3D System team for the support, for the marketing and the support which you gave for the webinar. Also, big thanks to all the Sri Rapid Technologies team for organizing this session, and very thankful to audience who has been so engaging and active in asking questions and even interactive poll. So after this session there will be a feedback. Please do fill the feedback, whether it is about the content or format or the topic, so which you like us to cover in future. Also feel free to contact us on the given screen. That is our number. You can contact to our expert. Also, if you want to write a mail to us, you can write at marketing at Sri Rapid Technologies. We also welcome you to our Customer Innovation Center that is in Mumbai, where you can experience the 3D printing technologies live. We have printed several parts and benchmarked also many parts there with an impressive detail and accuracy. If you are interested in a live demo or want to get your own parts benchmarked, so we would happy to help you. Thank you again. Thank you everyone for attending this session, and please be connected to us. We are organizing few more webinars next. We have on atomizer as well as BMF microfluid technology. So please, we will be connecting you through emails, WhatsApp, and social media. Also follow us on social media. We will give you more feedbacks on the same, and we can also meet you in exhibitions which will be having in future months. Thank you everyone, thanks a lot. See you next month. Thank you.